Listen, everyone turned their gaze to the sun. Sun flares, storms, cycles, all this certainly matters, but it's just known background noise. Everyone is focused on this noise. And at that moment, a truly significant signal comes from the silence. And here it is. From Chile. A telescope, a manoeuvre, and a ruby. By the way, quite good tools. The iron does its job, capturing the object. 3. A departure. The third. Just the third interstellar guest we have ever confirmed. At first glance, everyone will just shrug. A comet from another system. Great. And they will return to their coffee. But that is a mistake. A fundamental mistake of perception. People see what they want to see. They perceive it as a comet. But it is not quite what we consider a comet. Let's figure it out. What is a comet? A dirty snowball. An icy lump. Physics is simple. We bring it to a heat source, to the sun. It begins to melt, sublimate, gas, dust, all of this. This process, according to our calculations, starts somewhere between Mars and Jupiter. It gets warm enough there. But here are 3. A crust. This object activated when it was far beyond Jupiter, in space. There isn't enough energy to initiate such a reaction. Just count the photons per square meter. The numbers don't add up. It's like finding a car in the desert with a fully functioning engine but no gas or battery. How is that possible? The scientific community has certainly tried to find an explanation. Perhaps there's some special nitrogen ice? Let's assume. But even then, consider the energy balance. The coma is a gas cloud measuring 43,000 kilometers, larger than half the diameter of the sun. Creating such a structure requires energy that exceeds all our models by orders of magnitude. This is not just an anomaly. It is a serious violation of the rules. It seemed that this object had its own energy source, a sort of onboard reactor. And the most interesting part, usually a comet dims and burns out as it approaches the sun. But this one became brighter, more active, as if something inside it was not just working, but reaching full power. Science, of course, faced an insurmountable obstacle. All our models, based on thousands of known comets, turned out to be useless. It's like trying to understand an internal combustion engine by studying only steam engines. You lack the necessary tools. And this is where the most exciting part begins. On the eve of its closest approach to the sun, the object disintegrated. But not like a comet usually breaks into several pieces. It exploded, and the Hubble telescope captured it. Dozens of fragments scattered along their trajectories, as if someone pressed the self-destruct button. This too makes no sense. An interstellar object must be incredibly durable. It has traveled for billions of years through galactic trials, radiation, gravitational fields of other stars. He must be a hardened fighter, yet here he has been reduced to dust by the pull of our seemingly unremarkable sun. I cannot believe it. This does not fit my understanding of reality. Either he turned out to be extremely fragile, which is strange, or his destruction was the result of that very inner process we mentioned. Think about what this could mean. It means we received a package from another star system, a unique specimen of extraterrestrial matter, and this package self-destructed right before our eyes, before we could unpack it. What if it was not just a body, but a probe? What if its task was not to reach us, but to perform some function and disappear? And here we move from astronomy to questions of civilization survival. Someone might sigh in relief, thinking that it has fallen apart and the threats have passed. But no, everything has only gotten worse, much worse. Now instead of one object, we have a whole swarm of debris with a completely unknown chemical composition. This swarm will interact with the sun's magnetic field, and we had already encountered something similar in the year 2023, when a regular comet caused unexpected disturbances in the solar wind. This forced us to recalibrate the satellites. Now imagine that an active cloud of nuclei surrounded only by conducting plasma enters our system. The effect could be nonlinear and catastrophic, and all of this happens at the peak of solar activity. In the year 2024, we lost dozens of Starlink satellites due to a single flare. Pilots around the world report communication failures. Our technological civilization is extremely vulnerable, hanging by a thread of electromagnetic stability. And we have just added a huge unknown variable to this equation. So the question is not what this strange comet was. The question is what its demise means for us. If objects from the depths of space violate the known laws of physics and then explode, becoming a potential threat to our infrastructure, What else do we not know? This deafening cosmic silence after its destruction tells us one simple truth. We control nothing. We sit on one planet, and our physics textbooks may describe only a small part of reality. We must realize this and become a multi-planet species, not because it's fashionable, but because it's the only way to protect ourselves from the unknowns that are already knocking at our door. The next package may not self-destruct. If the hypothetical interaction with the cloud of fragments Atlas indeed leads to increased solar instability, then this effect will no longer be purely theoretical. It will reflect in the most direct and destructive way on all our lives, on important infrastructure. This will affect the work of the global internet network, GPS systems, upon which almost all modern transport depends, the stability of electrical grids, the functioning of global financial markets, and even hospitals that increasingly rely on complex equipment connected to the global network in real time. Here arises an inevitable and rather alarming historical analogy. It concerns the famous storm that occurred in Carrington in the distant year of 1859, when powerful solar activity literally disabled telegraph lines across Europe and North America. In our time, when orbital satellites control almost everything, from simple banking operations to complex military actions, the consequences of such an event on a larger scale would be catastrophic and much more serious. This concerns not only our technologies. There is also an important social aspect to this problem. Every time news reports appear about new interstellar objects, we observe the same pattern. At first, there is a wave of collective enthusiasm and genuine interest, but then it quickly shifts to either complete silence, outright disbelief, or even mockery. This was the case with the object Oumuamua in 2017, when some bold scientists like Avi Loeb proposed extremely unconventional hypotheses about its possible artificial origin. However, soon all disputes on this matter were halted, and any assumptions were declared marginal, despite the lack of convincing and widely accepted explanations for its anomalous behavior. The same is happening now with the Saturn. The public narrative shaped by the media emphasizes the spectacular visual effect of its decay, while carefully avoiding the most important and uncomfortable question. Why did he exhibit such behavior that is considered absolutely impossible from the perspective of modern scientific understanding? Such collective attitudes undoubtedly have far-reaching consequences. By downplaying such anomalies, we risk not only overlooking real threats, but also missing unique scientific opportunities that may never arise again. Imagine for a moment that the material of Atlas contains chemical compounds previously unseen in our solar system. These newly formed fragments could radically expand our understanding of planetary formation processes and possibly shed light on the unique chemical conditions necessary for the emergence of life. To ignore such an opportunity is to consciously miss a priceless chance to learn from unexpected and unpredictable phenomena. As a civilization, we seem completely unprepared to face something truly unknown, especially if it doesn't fit within our usual scientific frameworks. Our subconscious desire to quickly normalize or even ridicule any abnormal phenomena can serve as psychological comfort, but it also poses a serious danger. Perhaps this is the main lesson we can learn from the Atlas. The universe is not obliged to conform to our narrow and limited expectations. These discussions should not remain within the confines of academic circles and scientific institutions. They directly pertain to all aspects of our society, from energy companies and airlines to digital banks and government structures. They all critically depend on complex technological systems that may be extremely vulnerable to the effects of a single, powerful solar flare. What will happen if one night without the internet turns into prolonged weeks of global power outages? The price of such an event will be not only economic but also psychological, social, and ultimately civilizational. For this reason, it is important to closely monitor every new fragment of incoming data, updates, and reports from astronomers. This is not about inciting panic for no reason, but about the necessity of maintaining a high level of critical awareness. Ultimately, it is this vigilant and attentive approach to the surrounding world that distinguishes those who react too late from those who can foresee and prepare for future events in advance. In our complex and interconnected world, even one informed observer can play an important role, pressuring authorities for timely preparation and actively sharing verified information. Therefore, subscribing to resources and channels that explore such complex and ambiguous phenomena is not just a manifestation of curiosity, but a real way to avoid surprises in the future. However, there is one more important aspect that could radically change this tangled story. So far, we have mainly discussed the hypothetical risk of electromagnetic interaction with the sun and its possible consequences for Earth. However, It is rarely mentioned that the disintegration of Atlas left behind real physical fragments that continue on their trajectory, crossing the orbit of our planet. According to calculations, in the year 2026, Earth will pass exactly through this path. Thus, we are faced not with an abstract, ephemeral threat like the intensification of solar flares. We are about to literally fly through clouds of dust and small debris from this mysterious interstellar object. What we managed to discover during this unique meeting could fundamentally change our understanding of planetary security, the phenomena of life in the universe, and ultimately, our own future. When we contemplate possible cosmic threats, our imagination often conjures images of catastrophic collisions, giant smoking craters, and scenarios of mass extinctions. However, the case of the comet 3 returns presents us with a much more subtle, complex, and troubling task. Sometimes the most significant impact is not physical, but intellectual, implying that civilization must realize that objects from other stars not only exist, but can behave in ways that fundamentally contradict our basic physical laws and models. The sudden and complete fragmentation of Atlas is not just another interesting astronomical event, but a brutal and sobering reminder of the limits of our understanding. For centuries, we have completely trusted the idea that the entire cosmos is governed by universal and unchanging laws, and that the knowledge we gain from observing Mars or Jupiter applies to the most distant and exotic celestial bodies. But when an interstellar guest explodes right before our eyes, leaving many questions unanswered, a deep and philosophical wound opens in our scientific worldview. How much of our confidence in understanding the surrounding world is merely a well-organized and convenient illusion? This dilemma resonates in another, no less important area, the philosophical. For centuries, the universe has been perceived as a mirror of our own mental categories and representations. We instinctively strive for order, predictability, and the search for meaning in everything around us. But what if the cosmos is not created for human understanding? Atlas, with its unimaginable and abnormal activity, as well as its equally inexplicable and sudden demise, persistently reminds us that perhaps the universe is not just a convenient stage for demonstrating the power of our reason, but an abyss of deep mysteries that go far beyond scientific language and methods of knowledge. The gaps in our knowledge are obvious and significant. We still cannot confidently say what this object consisted of. We have no idea why it began to glow so anomalously early. We are unable to explain why it suddenly completely disintegrated, and we have no idea what consequences his field trace will have when interacting with our atmosphere. 4 key questions remain unanswered. Nevertheless, public opinion, fueled by the media, is already trying to present this story differently. For many, Butte became just another unremarkable comet. This clear discrepancy between the scale of the mystery and the reaction to it indicates a deep collective failure. We strive to restore everything to normal as quickly as possible to avoid the deep discomfort that inevitably accompanies such events, which leads to real civilizational consequences. If we really have to pass through vast clouds of interstellar debris with no understanding of its composition and possible consequences, it could affect not only science, but also the stability of global politics, the economy, and even the very foundation of the existing social order. What will happen if in the year 2026 a collision with debris causes unexpected and unpredictable chemical reactions in the upper layers of the atmosphere or creates long-lasting interference with satellite operations? Our financial, defense, and communication systems may be partially or completely paralyzed. At first glance, an unnoticed trace of cosmic dust can vividly demonstrate the fragility and vulnerability of the complex technological civilization we have built with such effort. What if the appearance and destruction of debris is not just a coincidence? The hypothesis that it functioned as a kind of giant interstellar dandelion, deliberately spreading its seeds upon entering a new star system, may seem overly speculative at first glance, but it carries potentially destructive philosophical consequences. Perhaps for the first time in history, we have encountered a form of directed panspermia, a complex cosmic mechanism for seeding distant worlds with life. If this is at least partly true, the thin line between strict science and ancient myths will become much more blurred than we could imagine. This discomfort intensifies when we remember that Atlas is only the 3rd interstellar object ever discovered by us. The first was the mysterious Oumuamua, which passed by so quickly that we learned almost nothing about it. The second, Borisov's comet, turned out to be too familiar and similar to our comets to provide any new answers. And now Atlas leaves us a complex puzzle, full of missing and possibly forever lost fragments. A question arises that cannot be ignored. How many more such messengers have gone unnoticed throughout Earth's history simply because we did not have sophisticated enough tools to detect them in time? These mysterious objects, even when damaged and broken, function as peculiar mirrors. They reflect not only the boundlessness and enigma of the cosmos around us, but also the sad limitations of our understanding. Every time we gaze at the starry sky, we sincerely believe that we are gradually uncovering its great mysteries. However, perhaps we are just trying to decipher signals that were never intended for our perception. Human pride makes us perceive the universe as a mere backdrop for our lives. Meanwhile, we might be just a minor detail in a vast and incomprehensible narrative. While 3 atlases have vanished, but their shadow remained with us forever, urging us to confront the fundamental paradox. The more we gaze into space in search of final answers, the more it presents us with questions that undermine the foundations of our beliefs. Are we ready to embrace the abyss of the unknown, or will we prefer to stay in our comfort zone, satisfied with simple and convenient answers, even as the unknown persistently knocks at our door? Such complex questions require us to maintain constant intellectual vigilance and the ability to resist panic or unfounded speculation. Instead, we must develop critical thinking that can see beyond official and simplified interpretations. Space itself does not provide answers. It provokes, challenges, and demands more from us than mere self-satisfaction. Therefore, such discussion spaces where bold ideas can be freely discussed are of immense value. They allow for uncomfortable questions, exploring alternative hypotheses, and thinking outside the box, going beyond the accepted norms. If you have reached the end of this text, you likely share this deep anxiety and desire for knowledge. The true meaning of looking at the night sky lies not in seeking comfort, but in bravely accepting the discomfort that comes with understanding that perhaps the universe watches us much more closely than we watch it. This cosmic narrative also touches upon a more ancient and fundamental string of human consciousness: religion. For millennia, people have looked at the sky not only with scientific interest, but also with reverent awe. Comets, meteors, eclipses, all these phenomena were invariably perceived as signs from above, messages from the gods or omens of great changes. In every culture and civilization, celestial travelers always found their place in the myths and legends of sacred texts. They appeared as messengers of both divine grace and inevitable wrath. The birth and departure of rulers, the onset of wars and epidemics, harvest and famine, all were somehow linked to the appearance of comets in the night sky. And so, in the 21st century, in an era when it seemed that science and rational thinking reigned supreme, an object emerges that violates all known laws of this very science. How can religious consciousness react to this?